Hey everyone, for this problem here we want to graph this square root function. We have y equals the square root of x plus 3. And in order to graph this, we're going to have to do a little bit of strategic picking of our x values. We had talked about in class picking good numbers, we called them, for our x values. And just as a reminder, our good numbers is a number for x. Let me write this down as I go here. So values for x that produce a perfect square inside the radical. Okay, so remember, if we want to take the square root of something, I like to take square roots of perfect squares. Otherwise, I'd get these nasty decimals. I'd have to calculate this using a calculator. I want to do this stuff by hand. So I want to pick good numbers for x. So if I'm thinking about making an xy table then, let's do that. I want to think about the first four. I like 4 or 5 of my good numbers for x. So the first good number is going to be whatever the lowest possible perfect square is. That lowest possible perfect square is 0. So I'm trying to think of what number could I put in for x that would give me a 0 on the inside of this radical. So that's going to be -3. And I think what I'll do over on the side here is I'm going to kind of write what my desired radical is. So this is like my 0. My next perfect square is going to be whenever a 1 is underneath the radical. My next perfect square will be a 4, and then finally I want to find what good number will give me a 9 under that perfect square. So let's keep going here, and we're kind of looking ahead to see what x values I can use. So if I plug in, let's see, -2 in for x, that's going to produce -2 plus 3 is going to be my 1. Next good number, if I put in a 1 for x here, I'm going to get a 4 out. And then finally, I want this whole thing to equal 9. So I'm seeing a 6 is going to go in there. Now, this should make sense that my starting x value is at -3 because right off the bat, this x plus 3 on the inside of my radical tells me I'm going to have a shift to the left 3 units. So it makes sense that my first x value is -3. So from here, I'm going to be plugging in my x values into my function and evaluating for y. So we have y equals the square root of -3 plus 3, and that's going to be the square root of 0, which is equal to 0. So my first coordinate is this one here. Next, I've got y equals the square root of -2 plus 3, which is equal to the square root of 1, and that's going to equal 1. So there's my next y value. And then I'm going to plug in this 1. I have the square root of 1 plus 3, which is the square root of 4, which is equal to 2. So there's my next one. And finally, I have, let's go with this color here, y equals the square root of 6 plus 3, which is equal to the square root of 9, which is equal to 3. So here are my 1, 2, 3, 4 values, or 4 points that I'm going to plot from this table onto this graph. So here we go. Let's go blue here. So -3, 0 is my first point. -2, 1 is my next point. 1, 2 is my next point. And finally, 2, 3, 4, 5, 6, 1, 2, 3 is my final point here. And we have this sideways looking parabola, square root function thing, swimmer's arm, whatever you want to call it. And those of you who might have noticed, this follows the same, if you kind of turn your head sideways, this follows the same pattern as our normal quadratic equation or quadratic graphs, where I'm skipping over 1 point here, then over 3 points between these two, and then I'm skipping over 5 points to the next one, and that pattern would continue to 7 to the next point, and then 9 to the next point, and so on. So that pattern also helps you graph these things as well. The final thing that I want to do is I want to talk about the domain and range of this graph here. So if I'm talking about, let's go over here, the domain, those are all of my x values. And I'm seeing my x values, my furthest left x value is right here. I have no x values to the left of this point. All of my x values are from here onward. So that's going to be described as x is greater than or equal to -3. And then my y values for my range. All of my y values, I have no y values below y equals 0. If you can see, this is my bottom, my floor to this function. All the y values are increasing forever up in this direction. So my y is going to be greater than or equal to 0. And that's all I need to do for graphing this function.